Good morning, students. HS second year mathematics. We are doing chapter relation function. This is your first chapter, and exercise 1.1 is going on. First, you will do one that homework I have given. That one I want to show. Some of you have sent, but it is unfortunate that I found that is correct, but I cannot give the reply because my mobile is totally jam because so many files and so many classes are there are within this mobile. So that's why. So I will check this your hard copy and what I have done in this class. That's total you are copying in a page. That one I will check one day. That is when this regular classes will be there. Then that I will check. So those who have sent the homework, very nice. And now I want to show because some of you have not sent. So for them only I am doing, and those who have done, for them they have to check that whether your answer is correct or not. Your question was that homework what I have given is that R is what uh, xy. X is a father of this one y. X is a father of y. That is that one you have done. So here your homework that what I have given R is what x y. X is a father of y. That was your homework. So and we have to prove what this is reflexive, symmetric, and transitive. Now, if for any, this symbol is for any x belongs to a, x is not father of x. One cannot be father of himself. Anyone. It is the against our relation, against our rule, society rule that one cannot be father of himself. So x is not father of x. That is x comma x. This type of thing we cannot get in R. Implies R is not reflexive. So R is not reflexive. We have proved. Why? Because x cannot be father of himself. Now, if we take xy belongs to R, if we take xy, suppose xy is within R, x is father of y. So we cannot say then y is what? Son of this one, son or daughter of this one. So y is not father of x. Implies what? Yx cannot be within R. They are not, because son cannot be father, son or daughter cannot be father of father. So this is, so implies R is not symmetric. Then xy, yz belongs to R implies x is father of y. Y is what? Father of z. Because xy belongs to R, x is father of y. Yz belongs to R, y is father of z. So x is what? Grandfather of z. So x is not father of z, implies xz cannot be an element of R. Implies R is not transitive. So we found that this is the correct thing. So what is our that homework? It is neither reflexive, nor symmetric, nor transitive. So this is our homework. That those who have done, we check it. Those who have not done, we copy it. Okay, then we are going to start our exercise remaining sum. This exercise has a main thing that all the sum that given in the exam are what directly given from book. No need to do extra from this one. Now question number 4. It is we will start next. Last day we have done question number 3. Now question number 4. Show that the relation R in R defined as R equal to AB such that A less than equal to B is reflexive and transitive but not symmetric. So this is our question number 3. R is a real number and another relation R is what? AB such that A less than equal to B. We have to show it is reflexive, transitive but not symmetric. So this is our relation, and yes, of course we have to find that this A and B both are from real number. So for any A, if we take from real number, this A always less than equal to A. Equal to sign is there. 1 if you take 1 less than equal to 1, 2 less than equal to sign is there, so you can write. If it validates, then this can be said. Implies AA belongs to R. Implies R is reflexive. So we have proved one part, that they have said to prove that it is reflexive. Now, transitive. AB, BC belongs to R. This implies A less than equal to B, B less than equal to C. How? Because if AB is within R, A less than equal to B. BC, if it is here, then B less than equal to C. Then inequalities properties they showed. A is less than equal to B, B is again less than equal to C. So we can say what? A is less than equal to C. Implies R is transitive. So R is transitive. Now it is not symmetric. We have to give one example. 1, 2 belongs to R. Why? As 1 less than equal to 2. But 2 less than equal to 1 is not true. Implies 2, 1 not belongs to R. Implies R is not symmetric. So this is the case. When you have to show that your answer should come in negative, that is, you have to say that it is your not symmetric, not transitive, or not reflexive, then what you have to do? We have to give one example, and with that example only, if that it is fails, that means it is not possible. But if you have to show yes it is transitive or it is reflexive, then you see I have taken arbitrary element and I have proved. So this is our question number 3. Now question number 5. Check whether the relation R in R defined by AB, A less than equal to B cube, is reflexive, symmetric, or transitive. So question number 5. R is given AB such that A less than equal to B cube. One thing, it is neither reflexive, nor symmetric, nor transitive. It is nothing you can say. So first of all, you take half belongs to real number. Now half less than equal to half cube is false. 1 by 4 cannot be less than equal to 1 by 8. So implies half comma half not belongs to R. Implies R is not reflexive. See, I have given example to prove not, no. Then if I take 1, 2 within R, it is within R because 1 less than equal to 2 cube. But 2 less than equal to 1 cube is false. 2 cannot be less than equal to 1. So 2 1 we will not find within R, implies R is not symmetric. R is not symmetric. Then we will take example to 3 comma 3 by 2, 3 by 2 comma 6 comma by 5. These are belongs to R. Why? Because 3 less than equal to 3 by 2 whole thing cube, and 3 by 2 less than equal to 6 by 5 whole thing cube. See, 9 by 8, 27 by 8, of course it is greater than 3. 216 by 125, of course it is bigger than this one. But 3 less than equal to 6 by 5 whole thing cube is false. This is not true. This is not true. So implies 3 comma 6 by 5 not belongs to R. Implies R is not transitive. So this is the things. So this valid because 27 by 8, 27 if you divide by 8 then it is what? 3 point something, so of course it is correct. 216 by 1 by 25, of course it is greater than 1.5. So these are valid, but these are not valid because this one is less than 3. 216 if you divide by 125 then it is hardly 1 point something. This is, so 3 less than equal to this, it is not correct. That's why this one 3 comma 6 by 5, what we have to take 3 and 6 by 5, it is not within the R. So of course we will say this is not transitive. So now we have proved on this one, we have showed that it is neither reflexive nor symmetric nor transitive. Now we will do question number 6. 6 is, all of you have booked, that's why I am not writing the question, it is wastage of time. So that's why you can see the book also. In book question number 6 it is given, NCERT book, show that the relation R in the set 1, 2, 3 given by R is equal to 1, 2, 2, 1 is symmetric but neither reflexive nor transitive. So what question they said? They have given one relation. It is what? 1, 2 and 2, 1. And set is given what? It is 1, 2, 3. We have to say it is neither reflexive. No, first we have to prove it is not reflexive. For being reflexive, we should have 1, 1. We must have 2, 2. This should be within R, but they are not within R. Not a single one belongs to R. So this implies R is not reflexive. R reflexive na. Why? 1, 1 নেই, 2, 2 নেই, 3, 3 নেই. So একটা থাকলেও হবে না, সবটা থাকতে হবে। তো এখানে তো একটাও নেই, তো এটা রিফ্লেক্সিভ হবেই না। Then we have to prove it is symmetric. If we take 1, 2 belongs to R, 2, 1 belongs to R. See, or you can take opposite. 2, 1 belongs to R, its opposite 1, 2 belongs to R. Implies R is what? Symmetry. So we find what? R is symmetric. So that's why. Now 1, 2, comma 2, 1 belongs to R. 1, 2, 2, 1. You find these are identical. So for transitivity, 1, 1 should be within R. But 1 1, it is the not within the R, implies R is not transitive. So what we get? প্রথমে দেখলাম 1 1 2 2 3 3 কেউ নেই, একটা থাকলে হতো না, সব থাকতে লাগতো, তো একজনও নাই, এটার মধ্যে একজনও নাই, তো এটা রিফ্লেক্সিভ না। কিন্তু সিমেট্রিক 1 2 তারও রিভার্স 2 1 বা 2 1 তার রিভার্স 1 2 এটা আছে, সো আর ইজ সিমেট্রিক। ট্রানজিটিভ হতে গেলে 1 2 2 1 এই দুইটা সেম এগুলা জিনিস আছে, তো এটা বাদ দিলে 1 1 হয়, এটা নেই, তো এটা ট্রানজিটিভ না। সো নাও উই হ্যাভ প্রুভড that question number 6. Now 7. Question number 7 is like that. Show that the relation R in the set A of all books in a library in a college given by R is equal to xy, x and y have same number of pages is an equivalence relation that you have to prove. So question number 7, they say what? R contains xy such that xy have same number of pages. So we have to prove this R is an equivalence relation. These are, that is reflexive, symmetric, transitive, we have to prove. So here set is A, books in a library. For any x belongs to A, x and x have same number of pages. Suppose your maths book. Your maths book, 2-3 maths books are there in the library. So all of they are the same book. So number of pages should be same. So x and x should have same number of pages. Both have the same number of pages because the same book. One type of book can be more than one found in a library. So একটা বেশি বই থাকবেই, তো সেম বইয়ের তো নাম্বার অফ পেজ সেম হয়, implies x comma x belongs to R, implies R is reflexive. So R is what? Reflexive. So then xy belongs to R, implies xy have same number of pages. Now two books, suppose I am telling physics and maths books, physics volume 1 and maths volume 1 have the same number of pages. So maths and physics have same number of books, same number of pages. Shall I say physics and maths have the same number of pages? We can change the name. We can take this one first, this one, no problem it is. Y comma x have same number of pages, implies y comma x belongs to R. See, xy I have taken, yx is within R, implies R is symmetric. Why symmetric? Xy taken, yx we found within R. Xy comma yz belongs to R, implies xy and yz have same number of pages. Of course, x and y and z have same number of pages. As y is common, so shall I say x and z both have same number of pages, implies xz belongs to R, implies R is transitive. Why transitive? xy, yz we have taken from R and we found xz within R. Now R is reflexive, R is symmetric, R is transitive. So if one relation satisfies these three things, then R is equivalence relation. Already we have learned this one. that equivalence relation is like that, which have all the three qualities: reflexive, symmetric, transitive. Then its name is given as equivalence relation. Well, now we will do next question. Now, question number 8. Show that the relation R in the set A is equal to 1, 2, 3, 4, 5 is given by R equal to AB such that magnitude A minus B is even is equivalence relation. So this is first part. We will do the first part first. A is a set containing 1, 2, 3, 4 and 5. R is what? AB such that magnitude A minus B is given. Before doing this sum, here I want to clear something. Odd number 1, 2, 3, 4, 1, then out of this 1, 2, 3, 4, 5 we will take 1, 3, 5, 7. মানে বেজোড় সংখ্যা মানে কি 1, 3, 5, 7. জোড় সংখ্যা ইভেন নাম্বার মানে কি 2, 4, 6, 8. So even number is what? 2, 4, 6, 8 dot dot dot. Remember, when considering 0 যদি আমরা নেই, 0 কেও এখানে ইভেন ধরব. 0 we will consider here as even number. 0 is neither positive nor negative nor odd nor even. Still, in this case, we will consider 0 as what? Even number. 0 কে even number এই কনসেপ্ট রেখে এই অঙ্কটা করতে লাগবে. So let's start. For any A belongs to A, যে কোনো একটা এলিমেন্ট নিলাম. A minus A, it is 0, is even. See, already I have said, here concept is little bit different. যে কোনো নাও 2 নিলাম, 2 minus 2, 0, even ধরবো. কারণ এটা একটা কনসেপ্ট এইভাবে যে 1, 3, 5 দুই করে ডিফারেন্স, তো এদিকে নেগেটিভে দিয়ে গেলে নেক্সট ইভেন নাম্বার, নেক্সট অড নাম্বার -1 এসে যায়. আবার যদি ইভেন নাও 2, 4, 6, 8 এখানে দুই করে বাড়ছে, তো 2 কমিয়ে দিলে 0-তে আসবে, এরপরে -2 আসবে. এই কনসেপ্ট দিয়ে 0 ইজ ইভেন. সো A minus A, this is 0 is even, implies A, A belongs to R. ইভেন হলেই এটা R এর মধ্যে থাকবে. implies R is reflexive. R কি? reflexive. কারণ যে কোনো এলিমেন্ট নিলে এটা স্যাটিসফাই করে. If we take AB belongs to R, নিলাম suppose 2, 4. 2, 4 difference is what? 2. Or 3, 5. 3, 5 difference is 2. So implies modulus A minus B is even. এটা যে কথা, এটাও সেম কথা. কারণ 2 minus 4, 4 minus 2 সেম না, because minus sign will affect. But if we give the modulus sign, then both are same. কি সেম হয়? যেমন 3 minus 5, এটার ভ্যালু 2, আবার 5 minus 3, এটাও 2. এই মডুলাস এটাকে মাইনাস সাইন থেকে বাঁচায়. implies B, A belongs to R. Implies R is symmetric. So what we get? AB we have taken, we get BA. AB নিয়েছি, BA পেয়ে গেলাম R এর মধ্যে. So R is symmetric. Now, if we take AB, BC belongs to R, this implies this, this is even. দুইটা ইভেন হবে. এবার আমি যদি এটা লিখি implies A minus B plus B minus C, এটাও কিন্তু ইভেন হবে. মডুলাসের মধ্যে দুইটা ইভেন নাম্বার এড করলে ইভেন হয়. আবার একটা একটা ইভেন নাম্বার থেকে আরেকটা ইভেন মাইনাস করলেও ইভেন হয়, তার জন্য এটা ভ্যালিড হলো। I again want to repeat, as both of them are belongs to R, so this one is even. This difference, this one is also even. Sum of two even number is even, or difference of two even number is also even. এই কনসেপ্টে ভিতরের দুইটা যদি অ্যাড করে দিই তাহলেও ইভেন নাম্বার হবে। এক্সাম্পল দিয়ে ট্রাই করতে পারো। So this gives that modulus A minus C is even implies AC belongs to R implies R is what? Is transitive. R transitive হলো। So what we get? R is reflexive, R symmetric, R transitive implies therefore R is an equivalence relation. R equivalence relation. So I think this much is clear. Now second part of this sum we are going to do second part, that is first part they say to prove the equivalence relation. Second part করতে যাচ্ছি, show that all the elements of 1 3 5 are related to each other. If we take 1 3 5 with respect to this relation they are related to each other, এটা আমরা প্রুফ করতে যাব। তো 1 3 5 এর মধ্যে কি থাকে? Here if you take 1 1, see Cartesian product of these two sets 1 3 1 5. So 1 3 is 2, 1 3 that is modulus 1 minus 3, these are two differences, it is 4. Similarly 3 1 3 3 3 5 5 1 5 2 5 3 5 5. What is this? This is what? Cartesian product of this set with this one. So automatically এটা হবে 1 1 1 3 1 5 3 1 3 3 3 5 5 1 5 3 5 5. Student, you minutely watch that these are belongs to R. Is it belongs to R? Take any element, suppose 1 3. Modulus 1 minus 3 is what? 2, even number. 1 5. Modulus 1 minus 5 is what? 4. Like that, every difference you will find one. Hence, if I take this one as suppose B, better take X. Hence, all elements of X are related to each other. So this is the proof. That how this one. Now similarly they have given another part, that is 2 4. Whether these elements are related to each other. Why? If I take 2 comma 4, you will find that 2 2 2 4 4 2 4 4. These are also belongs to R. This is the Cartesian product I have written. And difference you find 2 minus 2 0 even, 2 minus 4 even, so everything this one. So here also, therefore all elements of Y are related to each other. Okay. Now last part, that is 1 3 5 is not related with this one. Now X Cartesian product Y. Because why you have to do? Because 1 3 5 is not related to 2 4. How to prove? So if I make the Cartesian product of this one, then it will be 1 2 1 4 1 2 1 4 3 2 3 4 5 2 5 4. Yes, this is what Cartesian product of these two set. Here 1 minus 2 is what? 1. So modulus of this one, it is not even. Modulus 1 minus 4 is what? 3. Not even number. 1, 1, 3, 1. They are not even number. They are not belongs to R. Therefore, no elements of X is related to any elements of So dear students, you see how to present our answer this way, because once if you do, then only you can able to solve this one. This is a main thing here, that is this first part to they said how to prove equivalence relation, that to already we have done. প্রথম পার্টে যে ইকুইভ্যালেন্স রিলেশন দিয়েছে সেটা তো করতে পারি, রিফ্লেক্সিভ সিমেট্রিক ট্রানজিটিভ দেখিয়ে দিলাম। নেক্সট পার্টে যে বলেছে যে এইটা, সেটার জন্য প্রথমটাতে এইটা এক্স ক্রস এক্স বের করে এটা করলাম, ওয়াই ক্রস ওয়াই পেয়ে গেছি, এটাও করলাম। নেক্সটে বলছে এটার থেকে এটাতে নেই, ইয়েস, তখন ক্রস করে দেখলাম যে সত্যি এটার মধ্যে নেই এটা। তো এভাবে আমি চেষ্টা করবো যাতে সবটা অঙ্ক করা যায়, যতটুকু পারি শেষ করে দেব। অ্যান্ড আই থিঙ্ক ইউ হ্যাভ লার্ন দিস থিংস, you have tried to understand also. Any doubt you will ask. Okay, that much for today.